Yeah, okay, great. All right, so as you guys are O-level students, grade 10 and 11 students, before starting the chapter, I just thought of giving you all an idea of the paper. All right, your O-level paper. Wait, some more have joined. Okay, fine. So if you take your O-level paper, students, you have two parts. Most of you guys know that we have two parts, paper one and paper two. All right. So in your full maths paper, you have paper one and you have another paper, which is paper two. All right. So in paper one, we have two sections. We have part A and part B. All right. And then if you take your second part, in that also the same thing. We have part A and we have part B. All right. So what you have to understand here is how the marks are distributed for these parts. Actually, for your part A, I mean the first paper, you will be getting 50 marks. So simply you will be getting 100 marks for your first paper, and the second 100 is going to be for your second paper. All right. So out of 200 only you will be getting the marks, and then they will give you the percentage as out of 100. That's how it's going to be. All right. And then what happens is like if you take your first paper, it's going to be a 2 hours paper. All right. You will be getting a 2 hours paper here. In this section, you will be having two parts. In the part A, you will be having short 25 question and each would carry 2 marks. All right. So altogether, you will be getting 50 marks here. And then in part B, there are main 5 questions. And I'll explain you all what are these 5 questions are going to be. All right. We will be having 5 main questions. So for each question, you will be getting 10 marks. All right. So 10, 10, 10, 10, 10. So for this, you will be getting another 50 marks. So your first paper is going to have 100 marks in this part, in this way only. All right. And if you take your second paper, okay, same way, you have 6 questions here, but out of the six, you have to answer only five. And in part B, also the same thing, you will be having 6 questions, you have to answer only five. All right. So for each question, you will be getting 10 marks. So 10 into 5, you would get 50 here. And then again, 10 into 5, you will be getting another 50 here. All right. For this, you will be getting 3 hours. Okay. So this is how your paper structure is going to be. And the other thing what you have to understand here is actually for your O-level paper, there's a format. Format in the sense like in which parts, what are the questions you will be having. That part is actually there in your O-level maths paper. All right. So how I'm going to teach you guys is going to be Lamai. I'll not be following the textbook lessons order. All right. Instead, I'll be covering from grade 6 to grade 11. Okay. From grade 6 to grade 11 in the sense from basics till your O-level parts for each and every chapter. All right. So for example, if we select the today's chapter fractions. So for the fractions, I'll be doing from basics till your O-level part. And then another chapter, like for example, area perimeter, same thing from basics to your O-level part. Percentage, whatever the chapter we are going to do, we're going to discuss from the basics to O-levels. All right. All right. And then the next thing that we have to understand is like we'll discuss what are the questions we're going to get over here. All right. So first, I'm going to focus on paper one, and then only I'll be moving on to paper two. So in paper one, we have two sections, as I already told you, part A and part B. So in the part B, we're going to see what are the 5 questions we're going to have. All right. Okay. So let's discuss that part one now. So we have part B in paper one. So we have 5 questions, and one question is going to be from fractions. but I think yeah. So one question is going to be from fractions. All right. And then with fractions, you can get inverse proportion question as well. Okay. So man, this question, we'll discuss that as well. Another question is going to be area perimeter. And the main thing, you will be getting area and perimeter only for 2D shapes here. 2D shapes in the sense two-dimensional shapes, which are going to be very simple, like square, rectangle, parallelogram, circle. Those kind of simple basic shapes only will be getting in this part for 10 marks. And you will be getting this or distance time graph question, which is simply like rates, speed, those things. All right. And then another question is going to be from data representation. Okay. Another question is going to be from data representation. So if you see data representation, under data representation, we have four subparts. Okay. We have four subparts. The first one is going to be pie chart. And the other one is going to be histogram. And frequency polygon. And cumulative frequency. Okay. All right. So in this, pie chart is there in your grade 10 textbook, and the rest you have in your grade 11 textbook. So we're not gonna discuss it separately, like grade 10 separately, grade 11 separately. We are gonna discuss as a chapter. Like if it's data representation, we're gonna do data representation from basics till O levels. So that's what we're gonna do for all the chapters. All right. So three questions done, and we have two more. Another question is gonna be from probability. So in probability, we have two parts. We have grid and we have tree diagram. All right. So you have probability in grade 10 and in grade 11 both. In grade 10, you have with replacement, and in grade 11, you have without replacement. That is the only difference you have in grade 10 and 11. But when it comes to your O level paper, you can get either with replacement or without replacement. It differs from year to year. All right. So four questions are done. And then the final question is going to be from percentage. All right. So under percentage, actually, we have five subparts. We have simple interest. We have compound interest. We have reducing balance, share market. I forgot to mention one. The first one is going to be rates, or we can take it as tax. Rates, income tax, but everything comes under this tax. All right. So in this, we have five. So out of the five, you can get anything. All right. Well, some are waiting to join. Yeah, all good. All right. So now technically, this is going to be your questions in your O-level paper. Paper 1, part B. All right. So this is going to be the paper structure. And another point you have to understand here is I told you, in percentage, there are five subheadings. You will be getting two questions, two 10 marks question out of these five chapters. One question will be, as we discussed, in paper 1, part B, and another one is going to be paper 2, part A. So if you know all these five chapters, actually, you can get 20 marks out of 200. All right. So that's how the paper is being made. So for your reference, let's have a look into the paper we have. Let me show you. All right, so hope you guys can see the paper. So this is 2023. So as I already told you, in the first paper, you have short 25 questions. All right. And then here we have the second part, part B, paper one, part B. The first question is going to be fractions. All right. And the next one is going to be area perimeter. Third one we have is under percentage, the tax question. Okay. And then we have probability. In probability, we have grid and tree diagram. And then we have the data representation. So these are the 5 questions you will be getting. And then you have your second paper. All right. It's going to be the same structure for the other papers also. Here we have 2022 paper. Okay. The first 25 questions. All right. And then we have the first 10 marks question is going to be under fractions, area perimeter, percentage, probability, grid and tree diagram, and then data representation. And then you have your second paper. All right. And then we'll look into one more paper, the latest paper we have, which is 2024 paper. Okay. In this also the same thing. After first 25, we have the fractions question. Okay, here we have distance time graph and area perimeter question. We have percentage, data representation, and probability. All right. Are you all clear with the paper structure now? So I can see there are some questions. Out of that 5, will we get everything or one? You mean the percentage out of the 5 percentage question, Malik? Okay, so it's going to be like this. Let me explain that part for you. Um, Here we go. So I told you, under percentage, we have 5 subheadings, okay? Simple interest, compound interest, tax, reducing balance, and share market. So out of these 5 lemma, you will be getting 2 10 marks question. All right. So in some years, you will be getting one full 10 marks for reducing balance. Only for reducing balance, you will get a 10 marks question. And for simple interest and compound interest, the other 10 marks question. In in another year, you can get share market for 10 marks question. Only for share market, you would get 10 marks. And for tax and simple interest, you can get another 10 marks. You got the point. So the chapters vary, but under percentage, you will be getting 2 questions. Did I make sense? All right. So as students, like you have to learn everything you have. Yeah. So then you don't have to worry about what would be the question you're going to get in your O-level paper. Simply under percentage, learn all these 5. Trust me, all these chapters are easy, not that a big deal. All right. If you know, if you can learn with the reasons, it will be very easy. Okay. Nothing to think much. So what happens is actually, you can actually, if you know all these 5 chapters under percentage, you can get 20 marks. All right. Any questions or any doubts so far? All right, great. All right. So as I already told you, I'm not gonna go with the textbook order. Instead, I'll be following this questions order. So simply we can complete the entire syllabus from grade 6 to grade 11, and also we can discuss question wise, which will make more sense when learning each chapter. All right. Okay. So I'm gonna start the reason why I selected this fractions chapter for today's class. All right. So my plan is like this. Actually, I'll be starting from the basics today. All right. Basics in the sense, very basics of fractions. And we'll try to complete up to grade 10 the concepts. And we'll try some questions. And also in the next week's class, okay, next Friday, we'll try to complete all the past papers we have. All right. So if we can complete the past papers, then like it's gonna be like we can complete fractions completely. Did I make sense? All right, actually that's my plan. So, and then rest is in your hand. You can try questions regularly, and if you do have any questions or doubts, you can reach out to me. Okay. All right. Anyways, in the EduZone website, I think I have uploaded the classified past papers. So moving forward, I'll be giving you all the remaining past papers as well. I mean the classified ones. If you take fractions, all the fractions questions from 2016 to 2024 for each and every chapter, right? So currently I have shared the fractions one. You all can download it from the website. You just have to log in as a student. Okay, if you have a contact number or an email address, log in through that, create a password, and you will be able to see my class profile. So under that, you will be able to get the classified past paper for fractions. Okay, wait, think I have got some messages here. Will you cover volume questions? Actually, yes, I'll be covering volume also, Umar Aiser, but I mean, not today, but moving forward, I'll be completing everything. All right. Uh, 10 okay. Adding classes for whole paper. Um, yeah, I mean, I think Tenuku, you are a 2025 old student. I'll be doing some seminars also, which would complete the entire syllabus in 2 or 3 classes. I mean, not for the grade 10, 11s, but for the students who are doing O levels in February. Okay. And then one more message to go. Let me check. Okay. I'm sorry. Can you please talk a bit louder? If you guys can't hear me properly, do let me know. All right. If anything is there, drop me a text. Or you can unmute and speak. Okay, so we'll start the chapter today. So starting introduction is done, so we'll start with the chapter today. All right, so the chapter we have to discuss today is fractions. All right. Oh, volume is a bit low. Is it all good now, Rushdi? Okay, great. All right. So the chapter we have to discuss today is fractions. And as a very basic question, can anyone tell me what actually fraction means? What's the purpose of learning fractions? So don't worry about making mistakes, just to try. What do you guys know about fractions actually? Okay, great, fine. So simply, Lamai, fractions means representing something out of a whole. All right. So remember this properly, representing something out of a whole in the sense like from one whole. All right. That is the purpose of learning fractions. Okay. I have got a very good try. Way of showing whole more than a whole, like showing something out of a whole. Okay. Like for example, if you have a pizza, okay, and we're gonna cut this pizza into, let's take 6 pieces. All right. And then let's take, you're gonna take two out of this. So if I ask you to represent the amount you have taken, then we can use fractions to represent this. If I say just 2 pieces, that doesn't make sense because we don't know how much pieces we have for the whole. Like for example, let's take we have the same pizza, but this time we're going to cut this pizza into 4 pieces. Same size pizza, okay, but we're going to cut into 4 pieces, and you're going to take two of this. If I say you have taken 2 pieces, like literally both would be meaning the same, which is incorrect. All right. So when you're representing something out of one whole, we can use fractions. Then it would make more sense. All right. So what I can do is I can represent this like this. You're going to take two pieces out of 6. All right, this is actually a fraction representing something out of one whole. All right, okay, so apart from this, what you should understand here is how to name them. Most of you guys would know this. For the top number, we see this as a numerator. All right, and for the bottom number, we see this as a denominator. All right, okay, so fine, now we know what is actually a fraction is. All right, so now we'll see what are the types of fractions we have. Anyone know how many types of fractions we have? Altaf, what you said is correct. We'll come to that. All right, good way, good job. So can you tell me? Very good. We have 3 types. What are the 3 types? Basically, we have 3 types. Okay. So what are the 3 types of fractions we all know? Mm-mm. Good one then. Okay. Proper, improper, mixed, unit. I can see many answers. Thank you for answering. Good job. So basically, Lamai, we have 3 types of fractions. Okay. The 3 types are gonna be proper fraction, improper fraction, and the third one is gonna be mixed number, not fractions. Just should be mixed number. All right. So I can see some of you guys have given the answer as unit fraction. Correct. But what you have to understand is unit fraction is a sub part of proper fraction. Unit fraction comes under proper fraction. All right. Okay. So now you all know there are 3 types. We have proper fraction, we have improper, and then we have mixed number. All right. Now we'll see what are the differences between these things, these fractions. Okay. So simply, okay, so I'll ask from you guys itself. So can anyone tell me what is a proper fraction? 2/3. Okay, that's an example. Good job.
Denominator is higher than the numerator.
Well done. Okay, denominator is going to be greater than the numerator. Any other answers? Okay, the other way around. The numerator is smaller and the denominator is greater. Good job. All right, fine. So, all right. So actually, that is not the definition of proper fraction. All right. So it's fine. Like even I was schooling, I have been taught in that way numerator is going to be smaller than the denominator, which is proper fraction. But actually, proper fraction means that is not the definition. The definition of proper fraction is going to be fractions which are less than one whole. Okay. So at the beginning itself, I'm saying y'all, whatever the things you guys are learning, try to learn with reasons. Just for the sake of I'm saying, don't accept anything. All right, you have to understand what is the reason behind this. When it comes to maths, everything matters if you know the reasons properly. Okay, so proper fraction is going to be fractions which are less than one whole. This is simply a proper fraction. All right. So most like almost everyone said numerator is going to be smaller than the denominator, or denominator is going to be greater than the numerator. That is like a strategy we can figure out to find a proper fraction. Okay. In that way we can find whether a fraction is proper or not. But actual definition is fractions which are less than one whole. All right. Okay. So for that I'll give you all an example. Let's take um the same example. Let's take we have a pizza. Okay, so I'm gonna cut this into 6 pieces, and if you take one of it, How can I represent it as a fraction? We can say this as 1 over 6. Good. And if you're going to take two pieces, it's going to be 2 over 6. 3 means 3 over 6, 4 over 6, 5 over 6. And then if you take the entire pizza, we can say 6 over 6. So technically, the whole pizza. All right. Okay. So here, until this whole, the previous ones are literally smaller than one whole or less than one whole. Do you all agree with me? Yeah. So for this only we say proper fractions. If your portion is less than one whole, we call this as proper fraction. In order to figure out a proper fraction, we can use the strategy, which is like numerator is going to be smaller than the denominator. Did I make sense? Okay. The next thing. Wait, there are some messages. Okay. All right. Now, for example, let's take someone as an example here. Okay, let's take Altaf. Altaf, right? Yeah. Okay. So now Altaf ordered a pizza. Okay, and there are 6 pieces. Earlier he had one, and then the second one, third, fourth, fifth, and finally he has. Uh, wait, there are some messages. Okay, all right. So let's check. He has completed the entire pizza now. He has had like the entire 6 pieces in it. Now he's even more hungry. Okay, he's gonna order another pizza now. All right. Now, if he has this first piece, now can you tell me how many pieces he has had altogether? What do you think? Okay, okay, I can see two different answers. Fine. So actually, he has had 7 pieces now. Now, what should be my denominator? Would it be 6 or 12? Okay. Would my denominator be 6 or 12? Okay, fine. Thank you for answering. Okay, all right. Good job. Almost everyone is saying 12. Fine. So this is actually a common misconception we have mainly in all our students. Okay. The reason is because learning without reasons. Okay. If you understand the reason, like what is actually a fraction, what are the parts we have with proper reasons, it will be easy for you to understand this. All right. And trust me, fraction plays a major role in your maths, the entire syllabus. Literally, for many things, we have to use fractions. All right. Okay. So can you all remember at the beginning when I was discussing fractions, I told you a statement. What is a fraction? Representing something out of a whole. What is the meaning of a whole? How many holes? A whole means one whole. All right. So what you have to understand here is, Lemay, if you put the denominator as 12, 12 should be considered as one whole. Do you think we have 12 pieces for one whole? How many pieces we have for one whole? To make one whole, how many pieces we need? One whole pizza. There we go. Is that point clear now? So remember, always the denominator represents only one whole. Any questions? All right, so here actually the denominator should be 6. And if he's going to have 2 pieces, then it's going to be like 8 over 6. Are you all okay with this? And if he's going to have another, it's going to be like 9 over 6. Now, for example, let's say he's going to complete this entire pizza. So actually, he's going to have 12 pieces out of 6. So now tell me 12 divided by 6 is going to give you 2, which means 2 wholes. He has had 2 whole pizzas. Are you all clear with this? Any questions so far? If you do have any questions or any doubts, let me know. I'll explain to you all again. So if you don't have any doubts, can I get a thumbs up for me to move on with the next part? Okay, there are around 35, 36 students, but I can see only 2. Okay, thank you. All right, great. So the next part we have to look into is Lemay. Now we are done with proper fractions now. Simply proper fractions means fractions which are less than 1 whole. Now then what would be the definition of improper fractions? What is improper fraction now? It's going to be the other way around. Fractions which are less than 1 whole is proper. Then improper fraction is going to be fractions which are greater than 1 whole. Now does it make sense? I will clear with that one now. So if any fraction is going to be greater than 1 whole, this is going to be 1 whole now, 6 over 6. So anything which is going to be greater than that will be considered as improper fraction. So in 7 over 8, 7 over 6, 8 over 6, 9 over 6, 10 over 6, in everything, Altaf is going to have more than 1 whole pizza. So that is simply improper fractions. And that is the reason why we say numerator is going to be greater than the denominator. Because denominator is going to give you only 1 whole. So if you have more than that, obviously the numerator is going to be greater than the denominator when it comes to improper fractions. Are you all clear with this one now? Okay, great. So now I hope you guys understood what is proper and improper. All right. So simply proper fraction means less than 1 whole. I'm sorry. Proper fraction means less than 1 whole. Improper means greater than 1 whole. All right. Okay. Now we'll go to the next guy, which is mixed number. Now, can you all tell me what is this mixed number? Now, less than 1 whole is also done. Greater than 1 is also done. Now, what is this mixed number then? Equals to 1. That is 1 whole. But good try, yeah. Okay, so mixed number means not a big thing. Okay, that is simply another way of representing improper fractions. So actually we have 2 types, proper and improper. Another way of representing improper fraction is going to be mixed number. All right, very good. Whole plus proper fraction. So now I told now earlier Altaf ordered a pizza and he had the whole 6 pieces. And he's gonna order another pizza. All right, and let's say he is gonna have 3 pieces of this. Now, what is gonna be the yeah? So you guys can hear me, right? Okay, so great. So can you all tell me what is going to be the fraction of this? Am I lagging? Can you all hear me clearly? And by the way, would you guys mind using the comment chat in the sense the everyone's one instead of directly DMing me? Because in the like it's fine, but for me it's hard to check your messages. I might miss your questions. Okay, thank you. All right, yes. So here, actually, Altaf has had 1, 2, 3, 4, 5, 6, 7, 8, 9. He's gonna have 6 pieces out of 6 or 12. It's gonna be 6 because I told you the denominator will always represents one whole. Okay. All right. So the denominator is gonna always represent one whole. Therefore, we have to go with 6. Okay. Now, can you tell me, is this person like Altaf has had more than one whole pizza or less than a whole pizza? Simply more than one whole. Yeah, very good. All right. Now, let's say I'm coming to you and I'm gonna say you like, okay, Altaf had 9/6 of a pizza. If you guys know fractions properly, then you will understand. Okay, 9/6. So 9/6 means he's gonna have one whole pizza and three more pieces. You got my point. If you have a good idea on fractions, you will be able to understand this 9/6. For a normal person, they won't understand because this doesn't make sense if the person doesn't know fractions. Like 9/6 means how this is even possible. We have only 6 pieces, but from the 6, this guy is going to have 9. Did you understand that point? Okay. So when it comes to improper fractions, it's actually improper itself says no, it's not proper. It's not in the proper way. So what we are going to do is we are going to convert this 9/6 improper fraction to another way, which would make more sense, which would gives a meaning properly. All right. Actually, what we're going to do is we are going to take out the number of holes we have separately. So in 9/6, if this guy is going to have 9 pieces, how many holes we have in this 9 piece? How many holes we have here in these 9 pieces? There we go. We have one hole. Okay, we have one hole. And how many more pieces we have? We have 3. So we can write it as 1 whole and 3/6. Are you all clear with this? So simply mixed numbers means taking out the number of holes we have from an improper fraction and writing the remaining as a proper one. Got it? Clear with this, everyone? So simply for this mixed number, you can have like this. It's going to be a mixture of a whole number plus proper fraction. Are you okay with this? Any questions or any doubts so far? All right. Now, what if I give you a question for you guys? What if I ask you to convert let's take 25 over 6. So we know that this is actually an improper fraction because it's greater than 1 whole. If I ask you to convert these improper fraction to, let's take a mixed number, what would be the answer? I'll give 10 seconds to make it fast. Very good. I will clear with this one now. So one thing that you guys have to understand here is I didn't explain y'all anything on how to do improper fractions to mixed number. I didn't teach y'all any sort of workings on how to convert improper to mixed number. Yeah. So if you know the reason, you itself can create the steps. So now we'll see this, okay? Admit. Okay, so now we'll say this. We have 25 parts out of 6. So as we discussed earlier, the denominator represents one whole. Okay, so we have 6 pieces for one whole. And we have 25 pieces altogether. We have to see how many holes we can make out of this 25. Simply, we have to see how many 6 we have in this 25. So if you see the multiples of 6, it's going to be 6, 12, 18, 24. So technically we have 4 holes. All right, we have 4 holes. So we have 6 over 6, 6 over 6, 6 over 6, 6 over 6. We have 4 holes, and the remaining we have is another 1 over 6. So I can write this 6 over 6 as 1, this one as 1, 1, 1. So actually we have 4 holes and another 1 over 6. So answer is going to be 4 1 over 6. This is the conceptual idea on how to convert improper fractions to mixed number. If you know this properly, after learning something in the correct way, you can go to simpler steps. So that simple step is going to be dividing 25 by 6 and writing the remaining as a numerator. I think that's how you guys have been taught in your, previous grades. If you have to convert improper to mixed number, the steps you have to follow is like divide 25 by 6. And if you have remainder, write the remainder as a numerator. But no reasonings for that. Why you have to divide, and why do you think we have to put the numerator as a remainder? Got it. So the main thing is you guys have to understand the reason behind on everything you guys are doing. Now understood the reasons properly here? Anyone? Any questions or any doubts? Okay, great. All right, now we'll go to the other thing. All right, now I'm gonna give you the same question in a different, the vice versa. For example, let's say we have 5 holes and 2 over 5. Now here 5 is a whole, 2 is a numerator, and 5 is a denominator. Now tell me, if I ask you to convert this mixed number to improper, what would be the answer? Simple. Yeah, so we have 5 holes here. So we know that for one hole, we have 5 pieces. One hole is going to have 5 pieces, which means for this entire 5 holes, we will have 25 pieces altogether, 5 into 5. Yeah, so 5 holes means 25 out of 5. And we have 2 more pieces as well. So with that, the answer is going to be 27 over 5. Are you clear with this? Okay, great. And the next thing. Now, actually, I taught you all both the ways. Yeah, like converting improper fractions to mixed number and like Let me show you. Improper fractions to mixed number and mixed numbers to improper fraction. Do you all know the reason behind this? Why do you think we have to convert improper to mixed number? And when do you think we have to convert mixed numbers to improper? If you're learning properly, you should know those reasons also, right? So the main point is, Lamai, when it comes to calculations, when solving calculations, no, before that we'll see in the first pizza, let's take, okay, Altaf ordered a pizza, okay, and he's gonna give me 5 out of the 6 pieces he has. So he ordered a pizza, okay. All right. So in his pizza, there are 6 pieces. So he's gonna give me 5 pieces. All right. And then let's take Abdul Malik. Abdul Malik, I hope, yeah. Malik is also gonna order another pizza. Okay. Malik is also gonna order another pizza. And this guy is gonna give me 4 pieces. So now we'll see how much I have altogether. So Altaf gave me 5/6 and Malik is gonna give me 4/6. So altogether, I'll be having 9/6. Isn't it? Am I right here? Okay, all right. And then I'll later on I'll explain when we are doing addition subtraction. I'll explain why here the denominators should be the same. Okay. Now, answer is going to be 9/6. Now, than saying 9/6, if I say I have 9/6, this doesn't make sense. How come that be 9/6? Because one pizza itself have 6 pieces. How can I have 9? So when you're giving your final answer, if your final answer is an improper fraction, okay, if your final answer is an improper fraction, in order to give your answer in the proper way, we have to convert this improper fraction to mixed number. We don't keep, all right, we don't keep the final answer in improper form because it's not a proper form. All right. So 9/6 is going to be like 1 whole 3/6. And actually, we can simplify this further. We'll do that part later on. So finally, I can say the answer as 1 whole and a half. Okay, I'll do this later. I'll clear with this on the reason why we have to convert improper to mixed number. If your final answer is an improper fraction, we have to give the final answer in the mixed form. All right. Okay. So that part is done. Converting improper to mixed number is done. Now we'll see the other way around. Mixed numbers to improper. Okay. We have to do this when it comes to, like, for example, let's take you have a calculation to solve. Not the final answer. This time you have a calculation. So let's take, I am going to give you a question like this. 4 wholes 1/4 plus, let's take 3 wholes 2/3. Here you have to add the fractions. So when adding these two fractions, you guys will have to deal with 3 numbers actually. You have to deal with the whole, you have to deal with numerators, you have to deal with denominators, you have to deal with 3 things. But if you convert this mixed number to improper, okay, it's going to be like 17/4 plus 11/3. This time you will have to deal with only 2 things. Numerator, numerator, denominator, denominator. You got it. So the workings would be easier. Yeah, actually we have to see the LCM. That's the second thing. But working out the question would be easier because we have to deal with only 2 things, numerator and denominator only. But here in this case, we have to deal with whole numbers also. And this is a reason why you can convert mixed numbers to improper when you guys are solving questions. All right. Okay, good job. Yeah. All right. So that part is also done then. So we started with fractions. We discussed what is a fraction, and we discussed the types of fractions also. We have 3 types: proper, improper, mixed. The next thing we have to discuss here is, yeah, before that we'll discuss equivalent fractions. All right. This is the next heading. We're going to discuss a very, very, very important thing. All right. So simply, we'll make it very simple. Equivalent fractions means fractions which have the same value but in different numbers. Simple. That's it. Okay. Fractions which has the same value but in different numbers. Okay. Now, we'll take the same example. Altaf is gonna order a pizza, and Malik is also gonna order the same pizza. Altaf is gonna cut his pizza into two pieces, and he's gonna give me one. He's gonna give me one out of the two pieces he has. Now, Malik is gonna cut his pizza into six pieces, six equal pizzas, and this guy is gonna give me three. Now, can you tell me who has given me more? Is it Malik or Altaf? Actually, both have given me the same amount, isn't it? So this is simply equivalent fractions. Are you all clear with this? So representing the same thing, but in different numbers. Actually, both are same. It's something like this. Now let's take Altaf's one, okay? Let's take Altaf's one. Now, I'm not gonna change the shaded part. Instead, what I'm gonna do is I'm gonna cut this into six pieces. I'm gonna make this pizza into six pieces. So one, two. So now how many pieces we have altogether? We have six. And how many are shaded? Three. You got it. So I'm representing the same amount but using different portions. That is simply equivalent fractions. All right. And the second thing, if you have to figure out an equivalent fraction, for example, let's take, I'll give you the fraction like, let's take 4 over 6. If I ask you to find equivalent fractions for this, okay, there are different ways, different strategies you guys can follow in order to figure out equivalent fraction. Okay, one thing, very good. One thing is going to be, I can say this as 8 over 12. Okay, very good. We can say this as good try, Musharraf. It would be like 16 over 24, not 12 over 24. Yeah, so we can say this as, let's check 12 over 18, or we can say this as 16 over, what's the other one? Yeah, 24, yeah. All right. Okay, so now can you tell me what are the, I mean, what is a common thing you guys did to figure out these three equivalent fractions? What actually we have to do? We can multiply the numerator by 2. So the concept is, if you do something to the numerator, you have to do the same thing for the denominator as well in order to make the fraction equal. If you have to maintain the same fraction without changing its value, then what actually you have to do is, if you're going to multiply your numerator by 2, you have to do the same thing for your denominator as well. Now, in this case, you're multiplying your numerator by 3. So you have to multiply your denominator also by 3. The other one you're going to multiply by 4. Here also you're going to multiply by 4. Did I make sense? Yeah. All right. The second thing is, it's not only multiplication, we can do division as well. Okay. We can do division also, but the point is you have to do the same thing. So can all think of a number from which we can divide 4 and 6 by? We can divide by 2. Very good. So if you're going to divide your numerator by 2, you have to do the same thing for the denominator, which is dividing by 2. So the fraction would be 2 over 3. Are you all clear with this? Yeah. Okay. So equivalent fraction means fractions with the same value but in different numbers. That is the definition of equivalent fraction. And how to find equivalent fraction? We can multiply or divide both the numerator and denominator by the same number. All right. Okay. So that is equivalent fraction, multiplying or dividing both the numerator and denominator by the same number. Only for this division section, okay, under equivalent fraction, only if you are dividing, we have a separate name for this. We say this as simplifying fractions. I'll clear with this. So simplifying fractions comes under equivalent fraction, but only for the division thing, like making the fraction to the simplest form. So then you don't have to learn simplifying fractions separately, because that actually comes under equivalent fractions. Okay, yeah, sure. I'll explain that. You mean simplifying fractions, Himansha? Himansha? Is it simplifying fractions or equivalent fractions? Okay, anyways, I'll explain it again. So simply, equivalent fraction means, okay, for example, let's check, I'll take another example. Let's take um 10 over 15. Okay, so in order to find an equivalent fraction for this 10 over 15, there are two methods. Either I can multiply both numerator and denominator by the same number, or I can divide the numerator and denominator by the same number. All right, if it's division, I can divide both by 5. You got it? So answer is going to be, in 10, how many 5s we have? In 10, how many 5s we have? Himansha. Yeah, so in 10, we have 2 5s. Very good. And in 15, how many 5s we have? 3. Good job. Understood. This is simplifying fractions. If you're making the fraction to its simplest form, that is simplifying fractions. All right, clear with this? So in order to find an equivalent fraction, we can either multiply as well. If you multiply this by 2, you can multiply the denominator also by 2. This would give you 20 over 30. This is like expanding the fractions. So for both, even if you multiply or divide, this comes under equivalent fraction. But only for this division part, we have another name, which is simplifying fraction. Did I make sense? Okay, I think someone has updated the timetable. Okay, anyways, so we'll go back to the other one. So equivalent fraction is also done. So in any question, we can apply this equivalent fraction. So in the previous one here, I have written like 1 whole 3 over 6, right? So the fraction 3 over 6, I can further simplify. I can divide the 3 and 6 both by 3. So in 3, we have 1, and in 6, we have 2. So answer is going to be 1 whole and a half. All right. Okay. Let me check on this. Yes. You have your O-level timetable released. Thank you for sharing that, Salman. Yeah, it's on 23rd. Your maths paper is going to be on 23rd February and starting from 17th. Let's save this. Yes. Okay, great. So we'll go back to the chapter and the next one. So simplifying fraction is also done. Equivalent fraction is also done. All right. And then now we'll go to calculations. Okay, so let me ask you another question, okay? A question for you guys to think. Okay, so now let's take the same two example. Now, Altaf is gonna buy a pizza, okay? And this time this guy is gonna give me 5 out of 8. He's gonna cut his pizza into 8 pieces. All right, and he's gonna give me 5. And Malik, he is also gonna order the same size pizza, and this person is gonna cut his pizza into 5 pieces, and he is gonna give me 3. All right. Now, can you all tell me who has given me a larger portion of their pizza? Okay, we'll see. Is it Malik or Altaf? Okay, seems like Malik is a kind person. Okay, we'll see. Okay, anyways, now it's kind of a bit confusing, isn't it? Like, most of you might be guessing, okay, which one would be higher or lower. Now, instead of giving you these two fractions, what if I have given you like this? Um, Altaf is gonna give me 5/8, and Malik is gonna give me 6/8. In this case, who is gonna give me a larger portion? Which fraction is higher? Obviously, 6/8 is gonna be bigger. Yeah, it's easy for us to figure out because both the denominators are same. Yeah, okay. Now the problem in the question I gave you guys is that the denominators are not the same. That's a problem. So what's the solution we can, I mean, you guys can come up with? What you guys can do here? We can listen to this point properly. We can, yeah, what we can do is we can make the denominators the same. Listen to the steps properly. Listen steps in the sense like first understand the reason. Okay, what we have to do is what we're going to do is we are going to make the denominators the same. The reason is because if we have the same denominators, it will be easy for us to compare the two fractions. Understood the reason why we have to do this? Okay, so we have to make the denominators the same. The reason is because if the denominators are same, we can easily compare fractions. Now, we can make this 8 a 5, or we can make this 5 and 8. Then we have to do something else. We have to go out for a different number. Here only LCM comes to work. LCM means lowest common multiple or least common multiple. We'll learn about LCM in depth later on. So simply what I'm going to do is I'll, instead of using the LCM term, I'll use from what we learned. So forget about LCM for a while. What I'm going to do is I'm going to figure out an equivalent fraction for this 5/8. I'm gonna figure out another equivalent fraction for this 5 over 8 and also for this 3 over 5 with the same denominator. All right. So simply what I can do is I can make this 8 also to a 40 and I can make this 5 also to 40. Are you all clear with that? So simply I'm gonna figure out two equivalent fractions. So I'm gonna multiply this 8 by 5 to make it a 40. If I do anything for the denominator, we have to do the same thing for the numerator as well because we learned this in equivalent fraction. All right. So my fraction, new fraction is going to be 25 over 40. Is this point clear? So do you think this 25 over 40 and the actual fraction 5 over 8 are equal? Both means the same. Clear with this? Actually, both means the same because I multiplied both the numerator and denominator by the same number. Now we'll go to Malik's portion. How can I make this 5 to an 8? I have to multiply this by, I'm sorry, how can I make this 5 to a 40? I have to multiply this by 8. So if I multiply my denominator by 8, I have to do the same thing for the numerator as well, so that my denominator becomes 40 and my numerator becomes 3 times 8 would give you 24. There we go. Now, do you think still Malik is giving me more? Who is giving me more then? Which fraction is larger? Altaf. Is that point clear now? It's fine to make mistakes. The point is, you guys have to understand the reason behind what you guys have done. All clear with this? Any questions, any doubts? So I can say 5 over 8 is going to be larger. Are you okay with this, Lamai? So actually from this question, we have completed comparing fractions also. All right. So now simply what you guys, I mean, as a summary, if you have to compare two fractions, what we can do, we can make the denominators the same. So to make the denominators the same, you can use LCM. You can figure out the lowest common multiple. It's the point is, it's not that always LCM. You can go with some other multiples also, but going with the LCM is like to make the workings easier. That's it. If you want to, you can make this 8 and 5 as 80 as well. Actually, I'll give you all the recording so that you can take the screenshot later on, Malik. I think if I zoom it out, nothing will be visible actually. Okay, so anyways, I have recorded this session. The, yeah, the session is being recorded. Let me check. Okay, yeah, it's getting recorded. So I'll give you all the recordings. Okay. All right, so now comparing fractions is also done, equivalent fraction is done, the basic types of fractions is also done. Now, with these knowledge, like with what we discussed so far, we can move on to the next one, technically for grade 10 part. Not grade 10, it's there in your previous grades also, but mainly which will be tested in your exam papers. All right, the thing is, we have to discuss the operations now. Operations in the sense, the calculation. So can you tell me what are the basic operations we have in maths? Come on, what are the four basic operations we have? Okay, so it's going to be like addition, subtraction, multiplication, and division. All right, these are the four basic calculations we have. All right. And then with this, we have to discuss something called BODMAS also. We'll come to that point later. We'll see the basics first. Okay. So what I'm going to do is I'm going to select the first two first, in the sense addition and subtraction. Very good. Thank you for replying, Lemay. All right. So the first two things is going to be addition and subtraction. All right. So when it comes to addition and subtraction, most of you guys know one thing. If you have to add or subtract two fractions, the denominators should be the same, isn't it? You all know that? Good job. Okay, so yes, if you have to add or subtract two, okay, let me give you two examples. Let's take um Malik is giving me one third of its pizza. And Altaf is gonna give me, let's take 1/4 of his pizza. Okay. Now, wait, is everyone joined? Yeah, Zaid Ahmed. All right. So yeah, Malik is gonna give me one third of its pizza, 1/3, and Altaf is gonna give me 1/4 or 1/4 of his pizza. Okay. All right. Now, if I ask you to add these two in the sense like to figure out how much I have altogether, in total, how much I have altogether. So can I add these two fractions directly? What's the problem in this? I mean, I know most of like almost everyone know to get the answer for this. Okay, which is like you have to multiply this by 4, this by 3, this also by 4, this also by 3. So your new fractions would be like 4/12 plus 3/12, and the final answer is going to be 7/12. That's it. Okay, that's fine. I think almost everyone knows to get the answer for this. But what I'm trying to do here is, am I like to make you all understand the reason behind the steps you have done here? Because it's not about learning the steps. Anyone can do the calculations if they know the steps. The main thing is when it comes to learning maths, you have to understand the reason behind the steps. Because actually, that is the purpose of maths, learning maths in your O level things. All right. Okay. Now, the point here is one third means, Lamai, from the whole pizza, you're going to cut this into 3 and 1. 1/4 means the same pizza, you're going to cut this time into 4 pieces and you have 1 here. The reason why we can't add these two parts is because both the parts or both the pieces are not in the same size. Did I make sense? They are not in the same size. So if you have to add pieces, if you have to add fractions, the pieces should be in the same size. All right. That is the whole idea behind making the denominators the same. You guys know that we have to make the denominators the same to add. Now you guys know the reason. The reason is that the pieces should be the same sized pieces. All right. So in order to make the pieces the same, what I'm gonna do is we'll see Malik's one. I'm going to cut each of his piece into 4. Okay. I'm gonna cut like this, and like this. And again like this, like this, like this. So now tell me, in Malik's portion, how many pieces we have altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Altogether there are 12 pieces. And I didn't shade anything extra. Huh? Already I shaded only one partner. We'll see the number of pieces we have in that. 1, 2, 3, 4. We have four pieces now. Are you all clear with this? We'll go to Altaf's one. What I'm gonna do is I'm gonna cut each of his piece into 3. So I'm going to cut like this, like this, like this, and like this. So now tell me how many pieces we have altogether in Altaf's pizza. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Now he also have 12 pieces altogether. How many are shaded? 1, 2, 3. Understood the idea behind this now. Now, in both the parts, we have same sized pieces. Now, can you tell me who has given me more here? This time, Malik has given me more. I will clear with this one now. Now, altogether, how much I have? I have 7 pieces out of 12. Understood the reason? Everyone, all okay? Sure. Any questions, any doubts here? And this is the reason behind making the denominators the same. All right. And you will be wondering, okay, if we know how to solve this, then why the hell we have to learn these reasons and all? Actually, when it comes to your O-level paper, Amai, you will not be getting the calculations directly. They won't say you add 1 over 3, 1 over 4, or multiply this fraction by that fraction. That is for primary students. Okay. As O-level students, you have to figure out the calculation and then you have to solve. Did I make sense? And for that knowledge only, you should have the reasons. Like, let me share you the part, I mean, one of the past papers. Okay, let's take 2023. I mean, I'm not going to discuss this one now. We'll discuss this later on, just for you guys to have an idea. Okay, so here, see, they have given you a statement. It has been planned to construct a wall in 3 stages with the participants of the group of men. Okay, so in the first stage, 10 of them worked together for 4 days and completed 4 over 7 of the total length of the wall. You got it. So the question is like, so they have given you a scenario, like how many man days is the work done in the first stage of the construction. So I told you, no, this comes under, I think, wait, let me share you the screen for this whiteboard. At the beginning itself, I told you all one thing. When it comes to fractions, mostly the fractions will be connected with inverse proportion also. See, man days thing. So that is also have been connected there. All right. So we have to figure that out. Okay. So now I'll give you another past paper. Let's take. We'll see this one now. So just see, it is a very simple question, a full 10 marks, okay? See the first one. A household water tank is completely filled with water. 1 over 10 of the water in the tank is used to water the garden, and 1 over 4 is used for bathing. So the first question is, find what fraction of the water in tank is used to water and gardening. Sorry, used water to the garden and for bathing. So actually they're asking the total. So in order to figure out the total, what is the calculation we have to go with to find the total of garden and bathing? If you have to find the total of something, we have to add. Add. Very good. We have to add. So what are the fractions we have to add? We have to add the fraction of gardening and we have to add the fraction of bathing. Yeah. So for garden, it's going to be like 1 over 4. Sorry, 1 over 10. And for bathing, it's going to be like 1 over 4. Simply, you have to add these two fractions. Simply the basics, isn't it? So here, if you have to add the fractions, we have to make the denominators the same. So we can make the denominator to 20 here. So I can multiply this by 2, this by 2, this by 5, this by 5. So here we will be having like 2 over 20 plus 5 over 20. So altogether total is going to give me 7 over 20. That's it. You will be getting the marks for the first row. Are you clear with this? This is how your O-level questions are gonna be. End of the day, to work those things, you should have the basic knowledge. So if I give you, in that case, if the question says, okay, you have to add 1 over 10 and 1 over 4, anyone can do that. You got it. So here, if you know the reasons only, you can build up the calculation. You should know where we have to multiply, where we have to subtract. All right. You can think of those things only if you know the reasons. All right. Are you all okay with this, Lamai? Any questions or any doubts and in this addition? Can I take this silence as a no? Okay, great. All right. So the same concept work for subtraction also. If you have to subtract, the same concept, we have to make the denominators the same, because even when it's subtracting, the pieces should be same. Okay, we'll take the same example. Now Malik has 1/3 of a pizza. Okay, and we have to give 1/4 to Altaf. Malik has a pizza, and in that he has only 1/3 remaining. So from that he is gonna give 1/4 to Altaf also. Now we have to see what is the remaining Malik is gonna have for himself. Same concept. We have to make the denominators the same. So 1/3 becomes 4 over 12, and 1/4 becomes 3 over 12. So we can subtract this. So 4 minus 3 is going to give us 1 over 12. So Malik will have only 1/12 or 1 over 12 of the pizza for himself. All right. Muhammad has asked a question. I'm sorry, I think I have missed your question. Sir, can we take random numbers to make denominator and numerator to be the same? Actually, yes. All right. Actually, yes. For example, I'll give a question. Another common thing, okay? If I ask you to add, like, let's take 1 over 4 plus 1 over 6. Most of the students, what they do is they make the denominator as 24, isn't it? Simply what they do, they multiply this 4 by this 6 by this 4. Okay, we'll solve that and see, okay? So 1 over 4 means I can multiply this by 6, this by 6, this by 4, this by 4. So my fraction is going to be like 6 over 24 plus 4 over 24. Okay, the total is going to give me 10 over 24. All right, we'll go to another one. If you have 1 over 4 and 1 over 6, now can you tell me, Lamai, what is the actual LCM of 4 and 6? What is the LCM of 4 and 6? Very good, 12. And by the way, once again, a small request, would you guys mind using the um everyone option to send your messages? Because I might miss your messages. I think that's what happened for this one as well. So don't worry about others. Just whatever the questions you have, you can ask in the main itself. All right. I mean, it's up to you all. If you all want to just GM, no problem. But it's better if you can use the everyone's option. All right. Okay. Yes. Thank you for your answers, Lamai. Yes, it's going to be 12. The LCM is going to be 12. So in order to make this 4 a 12, I can multiply by 3. Okay. Numerator also should be multiplied by 3. The denominator also should be multiplied. I mean, in the second fraction, we have to multiply this denominator by 2 and this numerator by 2. All right. So the fraction will be like 3 over 12 plus 2 over 12, and the answer is going to be 5 over 12. All right. Now, do you think the two answers we have got are different? Actually, are they different? Actually, no, both are same. Is that point clear now? Because at the beginning itself, I told you, when we were doing equivalent fraction. So when it comes to equivalent fraction, a fraction should be given in the simplest form. So 10 over 12 means this is 10 over 24. This is not the simplest form. We can further simplify this. 10 and 24 both can be divided by 2. Yeah, dividing by 2. So in 10, how many 2's we have? We have 5. And in 12, how many 2's we have? We have 12. So answer is going to be 5 over 12. So which means technically, whatever the common denominator you take, you will end up with the same answer. You got the point? You can take a random multiple, a random common multiple to make the denominators the same. No problem at all. Are you clear with this? But the reason why we are learning LCM is because to make the workings easier or to make the calculations easier, instead of going with a bigger number to solve the calculation, it would be easy for us if we go with small numbers. Is that clear? That is the reason behind LCM. So if you understand the, expanded form of LCM, expanded form of LCM is going to be what? We can say it as lowest common multiple. Some people used to say it as least, both means the same. Lowest, least, both are same, okay? Multiple. So the two denominators we have are going to be 6 and 4, yeah? 4 and 6. So 24 is going to be a common multiple of 4 and 6. 24 is going to be a common multiple of 4 and 6. Not only 24, we can go with 36. We can go with 48. All these are going to be common multiples. So out of all the common multiples, 12 is the smallest one. Actually, 12 is also a common multiple. So we have many multiples, common multiples. So out of the common multiples we have, we are going to select the lowest one. That is simply lowest common multiple. Are you all clear with this? Okay. Yes. Is the first one mathematically correct? You mean the first way of solving, making the denominator as 24? Is that what you're referring to, Malik? Actually, yes, this is also mathematically correct. This is also mathematically correct because both gives you the same answer. You got it? So the point is, if you use the LCM, if you use the lowest common multiple of 4 and 6, which is 12, you will end up with the final answer directly. That is the advantage we have. Exactly. So must be simplifying the, it's not compulsory, but always you have, as grade 10, 11 students, you have to give your answers in the simplest form. So if you simplify your 10 over 24, if you add these two fractions, you're going to get as 10 over 24 now. So this is simplifiable. So if you simplify, you will end up with the answer 5 over 12. That's it. You got it? Any questions or any doubts? So the reason why we are going with LCM is because we can make the fractions, we can solve with small numbers. That is a main advantage. All right. Okay, so this part is also done. Now we'll go to, by the way, shall we work out some questions? Shall I give you all some questions to work out before moving on to the next one? before moving on to multiplication division? Let me give you, wait. Here we go. I hope you guys can see the question I have shared with you all. I'll give 10 seconds. Can all make it fast? So see, you have two improper, mixed numbers here. So think and work it out. Okay, so I can see different answers here. Oh yeah, some have given you answers in improper. Okay. Simra, you can make your fraction to mixed number because it's an improper, yeah. So if your final answer is an improper, as I already told you, you have to convert that to mixed number. All right, okay. So like many of you guys got the answers, yeah? So a common way of solving this question is going to be what? First, as a very first step, we can convert both the fractions to improper because when solving calculations using improper would be easy for us. So how to convert the first one to improper? We have 5 holes and each hole has 3 pieces. So for all these entire 5 holes, we will have 15. So simply 3 into, very good, yes. So 3 into 5, 15 plus the 2, it's going to give us 17. 17 over 3 minus the second one. 4 into 2, 8. 8 plus 3, 11 over 3. I'm sorry, 11 over 4. Now, the problem is both the fractions are not in the same size, different denominators. All right. So now what we have to do, we have to make the denominators the same. So the common denominator we can go for 3 and 4 is unlimited. Whatever the denominator you want, you can go, no problem. If you have to make it as, let's take 24, no problem, you can make it as 24. If you want to make it as 36, no problem, you can make it as 36. If you want to make it as 120, no problem, you can make it as 120. But if you go with larger numbers, the larger number you go, it's going to be more complicated. So that is the reason why we have to go with LCM. Out of the common multiples, we have to take the lowest one. The lowest common multiple we have is 12. All right, so I can make it to a 12. So I have to multiply this by 4. I have to multiply this by 3. So, sir, how to divide fractions? I'll come to that. After completing addition and subtraction, we'll go to the next one. Okay. So 3 into 4 is going to give us 12. Okay. And then 17 into 4 is going to give you, you can do like Actually, you can do some small basic. I'll come for those points also. When it comes to multiplication, we can use many mental calculations here. So when it comes to 17 into 4, you can do 10 into 4 first, 40, and then 7 into 4, which is going to give you 28. So altogether, the answer is going to be, come on, come on. Okay, it's going to be 68. Yeah. All right, minus. Thank you. Next, 4 into 3 is going to give us 12 again, and 11 into 3 is going to give us 33. So now we'll see the final answer. 68 minus 33. First remove the 30 and then remove the 3. From 68, if you remove 30, that's going to give you 38. And then if you minus another 3, that's going to give you 35. 35 over 12. So this is the final answer, but this is not in the proper order. This is actually improper fraction, more than one whole. So we have to take out the number of wholes we have. In 35, how many 12s we have? 12, 24, 36. So which means we have only two wholes. So the remainder is going to be 11 over 12. So this is going to be the final answer. All right. So can anyone tell me, did anyone try in a different way here, in different method here? Anyone tried the same question in a different way? Okay, fine. Um, Another point, Lamai. Okay, so when it comes to maths, whatever the question it is, there's no one way of solving a question. Based on the knowledge you have, based on the way you see the question, you can solve in different ways you want. Simply, the method you're using should be sensible. That's it. So shall I explain the same question in a different way? An even more easier way, actually. Okay. So what I'm gonna do is, see, in the first fraction, we have five wholes. Um, five wholes and two third. You have to minus two wholes, 3 over 4. What I'm gonna do is I'm gonna take away the wholes here first. How many wholes we have here? Five. How many wholes we have here? Two. So from the five wholes, can I take the three wholes? We can, yeah. So it's gonna be like 3 wholes, 2 over 3 minus 3 over 4. Did I make sense? Simply, I took away the wholes here. Now, we can use this normal method. 3 into 3 is going to give me 9. 9 plus 2, 11. Minus 3 over 4. Now I can make it to the same denominators. So it's going to be like 44 over 3 minus 9 over, I'm sorry, 12 minus 9 over 12. So this also would give me the same answer, which is 35 over 12. Okay, what actually I did was, I just saw the question. Here we have five holes, here we have two holes. Instead of making it to improper directly, I made the numbers smaller. From the five holes, I took away the two holes. So here we will have only three holes remaining. Here, no more holes. You got it. So we can use those kind of strategies here. All right. So for example, now using that, let's take another example. Let's say you have seven holes and let's take 1 over 2. From this, you have to minus three holes and let's take 1 over 4. Can you tell me the answer for this directly? Here, we don't have to make the we don't have to convert this to what do you call improper, the normal basic method everyone does. You guys can think a bit smarter here. So from 7 holes, I can remove 3 holes. So that's going to give me 4 holes. Okay, now from this fraction, we have to subtract this fraction. So it's something like from a half to minus 1 over 4. So I can make this to a I can make this 2 to a 4 by multiplying by 2. This also becomes 2. So simply it's going to be like 2 over 4 minus 1 over 4, which would end up with 1 over 4. So that's going to be my answer here. You got it? If you know something, don't always stick into the same thing, you guys. No, try to learn something new all the time. Did that make sense? So if you get a question like this, now you know to get the answer directly. So half minus quarter is going to give you another quarter. So it's going to be 4 wholes and 1 over 4. That's it. You got it. So, okay, hey Masha, what actually we have to do is from 7 wholes, I took away the 3 wholes. So from that, I got this 4. For the second one, what I did was from this remaining half, I took away this quarter. Take these two separately. Like from a half, you can minus this 1 over 4. So multiply by 2. You will get it as 2 over 4 minus 1 over 4. So answer is going to give you 1 over 4. So I can put that here. Clear with this? If not, what is a normal way? Like, see, within one line, we can get the answer. Na? If not, what actually we have to do? We have to do a long procedure here, long steps here. Okay, we have to, I think someone is drawing on the screen. Thank you. All right, so what actually we have to do? We have to convert this fraction to mixed number. I mean, we can do, would you mind stopping that, please? Okay, no worries. Okay, we'll go back to this, okay? So what actually I can do is, we'll keep the same fraction, okay? We have 7 wholes 1 over 2 minus 3 wholes 1 over 4. I'll make this fraction with the same denominator, which is 4. So what I can do, I can multiply this by 2, this also by 2. So my new calculation would be like 7 wholes 2 over 4 minus 3 wholes 1 over 4. All right, now what I can do, 7 minus 3, which is going to give me 4. And 2 over 4 minus 1 over 4, which is going to give me 1 over 4. This is also a possible method.
Sorry, sir.
Sorry? Okay, so yeah, are you all clear with this, Lemay? Wait, oh God. All okay? My bad. Wait. Okay, great. Um, Actually, I'm sorry, that was my mistake. After deleting, I just did it as undo. Okay. All right, so I'll clear with this, Lemay. If not the normal method, what we have to do, we have to multiply this 7 by 2, and then add the one. It's going to be like 15 over 2 minus 3 into 4, 12 plus 1, 13 over 4. And then we have to multiply this by 2. So it's going to be like 30 over 2 minus, I'm sorry, 13 over 4 minus, and then we have to get the answer. 17 over 4. And then we have to do the mixed calculation. You got it. So that's going to be a big working. So it's going to be like, what can you use it? That's going to be like 4 wholes and 1 over 4. We have to do a big working to get the same answer. So if you know the basic thing, from that, try to learn something new. Try to create your own way of solving. All right. Okay. Now we'll go to the next one. Let me give you one more question. With that, we'll move on to the other one, multiplication. Okay. Copy. Here we go. Okay, so I got 2 answers so far. I'll give 1 more minute. All right. Okay. Good job. Okay. So how many of you guys converted both the fractions to improper as your very first step? By the way, I'm sorry to interrupt you all. Simra has asked a question. Then, sir, we can apply this for easy calculations in the paper, right? Actually, yes. As grade 10, 11 students, you have to use simple methods to solve the questions. Don't go to ordinary basic calculations. You should know the basics. You should know how the long methods work. But after learning that, you have to go for simple working, simple mental calculations. Because you will be getting marks for the method, not for the steps. For example, let me show you the same fractions question you had. Wait, let me show you. So for example, here, let's take this one, this question. Okay, so the question is like, find what fraction of water in the tank is used to water the garden and for bathing, right? So here, you will be getting 2 marks actually for this question. The 2 marks will be for your final answer and for your method, not for the working. All right, it's something like this. In order to get the answer for this question, what is the method we have to use? What is the method we have to follow here? We have to add the two fractions. Okay, what are the two fractions we have to add? We have to add 1 over 10 and 1 over 4. This is the method. So for this, you will be getting marks, not for the way how you are gonna solve this. After writing the method, if you directly write your answer as 7 over 20, that's it. Even this is fine. For the method, you will be getting 1 mark. For your final answer, you will be getting your second mark. You don't, I mean, the steps for adding these two fractions are not necessary. And by the way, if you improve yourself in fractions properly by looking at these two fractions, 1 over 10 and 1 over 4, in your mind itself, you will be able to get the answer here. You got it? So for this only we say method. Steps means how you're going to solve this, how you're going to add this. For these basic things, that is not necessary. Understand the difference between method and steps. All right. Okay, so we'll go back to this one. Okay, so most of you might have done converting the two fractions to improper first. So 3 into 1, 3 plus 2, 5. So it's going to be like 5 over 3 plus 4 into 2, 8. 8 plus 3, 11. So 11 over 4. And then you can add these two by making the denominators the same. So it's going to be like, common denominator is going to be 12. No? So it's going to be like, you have to multiply by 4. 20 over 12 plus 33 over 12, which is equals to 53 over 12. And we have to see how many 12s we have in 53. 53 divided by 12 is going to give us 4 because 48, and we have 5 remainder, 5 over 12. Is this how you guys did? Any different way of solving here? Anyone? Okay, good job. What you can do here? Now, since you know from the beginning, from the basics we are learning now, no. So from this, from what you have learned, can you all tell me a simpler way we can do here? Always try to think out of the box. Don't go with the steps where everyone does. Simply what I can do as the very first step, I can add the two whole numbers we have. 1 plus 2 is going to give me 3. So forget about these 1 and 2 now because we know the total. Now we have 2 over 3 plus 3 over 4. Now try to add these two fractions. You have to make it to 12. So it's going to be like 8 over 12 plus 9 over 12. So this would give me the answer as what? This would give me the answer as, quickly, 17 over 12, yeah? So we'll convert this to, good try, actually 17, yeah? Altaf? Yeah, okay. So we'll convert this 17 over 12 to mixed number. In 17, how many 12s we have? We have 1, and the remainder we have is 5 over 12. So answer we got is 1 whole 5 over 12. Already we have a 3 whole now. Add that also. That would give me 4 wholes 5 over 12. You got it. Okay. So now, since you guys know this, I'll give you all another tip, okay? Another extra thing. Here we have this calculation now. From this, shall we come to the improper directly now? Okay, now see the point, huh? We have 8 over 12, which means from a 12 piece portion, okay, let's take there are 12 pieces here. Out of the 12, we have 8. Okay, so to make this into one whole, how many pieces we need from the other side? We need only 4 more to go. There we go. I mean, think differently, Lamai, okay? We need only 4 more. So if this person gives 4, this becomes 12 over 12 now, which is one whole. So it's going to be one whole, and this person will have only 5 remaining, which is 5 over 12. Got it. If you start to think, you will get even more different strategies, different methods to work out. Any questions, any doubts? Clear? Sure. Okay, so yeah, now we are done with addition subtraction. We are done with some of the calculations based on addition and subtraction as well. Now the next thing we have to do is multiplication and division. All right, so we'll go with multiplication first. Okay, so when it comes to multiplication, Lamai, there are two different things actually. Okay, multiplying a fraction by a whole number and multiplying a fraction by another fraction. Okay, all right. So first we have to understand from where this multiplication comes from, like the reason why we have to go with multiplication. It's something like this. For example, let's say if you have to um let's take we have 5 kilograms of sugar. Okay, in a bag we have 5 kilograms of sugar. All right. So from this 5 kilogram, we are going to let's take donate 2/5 of this. We're going to donate 2/5 of the sugar we have. So it's going to be like this now. 2/5 of the sugar we have. So the sugar we have is technically 5 kilograms. So I can write this as 2 over 5, 2/5 of 5 kilogram. Do you all agree with this? All right. So the meaning of this is simply we take off as multiplication. So the reason is because if we have 5 kilogram, we are going to make this 5 kilogram into 5 pieces because the denominator we have is 5. Therefore, we're going to divide the 5 kilograms we have into 5 pieces. So each would give us 1 kilo each. All right. And if we are going to take 2 of them, that is going to be equals to 2 kilogram. Understood the idea over here? Dividing the whole we have into the number of wholes we have and then multiplying by the numerator. If I give you something like this, let's say we're going to give 3/10 of 5 kilogram. Okay, the meaning of this is we are going to make this 5 kilogram into 10 pieces this time. And then we are going to take only 3 of them. So if you divide this 5 kilogram into 10, each would be like 500 grams. Okay, So if you take 3 of them, that's going to give you 1500 grams or 1.5 kilogram. Understood the purpose of doing multiplication? So we have a fraction from a total quantity. Are you all clear with this? Now, what if I ask you another question? Let's check. We're gonna get 3/5 of let's take 30 kilogram. What will be the answer for this? Make it fast. I got only one answer so far. What is going to be 3/5 of 30 kilogram? Okay, the same concept. Since the denominator is 5, we have to break this 30 kilogram into 5 pieces. Okay, 5 equal pieces. So each would be like 6, 6, 6, 6, 6. Since we are taking 3, that's going to give us 18 kilogram. Is this point clear? All right, this is a basic idea of this multiplication thing. All right, now we'll see the next thing. The easy way of solving, the normal way you guys used to learn. Of means multiplication. So what do? We can multiply 3/5 by 30. All right. So simply what we can do, we can simplify this 5 and 30. 5 and 30 both could be divided by 5. In 5, how many 5s we have? 1. In 30, how many 5s we have? 6. So the remaining thing we have is 3 into 6, which is going to give us same 18. This is one way. Or there's another way also. Instead of simplifying, what we can do, first we can multiply numerator to numerator. 30 into 3 is going to give you 90. So we have 90 divided by 5. This is also will give you the same answer as 18. All right. Understood this concept, Lamai? Like from a whole, we have to find the portion. Okay. And the next thing. Now, whatever the whole number you have, now you guys know how to solve. Yeah. So now if I give you a question like this, let's take um 4/5. Okay. 4/5 into, let me give you 8. Can you quickly get the answer for me for this? Okay. Good job, Ruif. Yeah. Okay. Yes. So most of you guys got the answer. So let me solve and show it to you. So simply, actually, we can simplify 8 and 5. So I just have to multiply this 4 by 8. 4 into 8 is going to give me 32 divided by 5. Okay. One option is what you can write this in mixed number. All right. In 32, how many fives we have? we have 6, and the remaining is going to be 2/5. If not, there's another way. We can divide the 32 by 5 in order to get the decimal answer as well. Okay, so let me give you another small tip here. Can you guys, without using calculators, can you divide 32 by 5? Okay, let me give you a small tip here. Okay, actually 32 divided by 5, right? What you can do is use the equivalent fractions concept we learned. Okay, so what actually we have to do, 32/5. Dividing by 5 is not that easy. Therefore, what we can do is we can try to convert the 5 to a 10, because dividing by 10 is easy for us, isn't it? You just have to move a decimal. So if you make this 5 a 10, what happens to the 32? We have to multiply this by 2, right? So what happens to 32? 32 becomes 64. Now, do you think dividing 64 by 10 is that hard? What happens if you divide 64 by 10? We just have to take one decimal place backwards. So answer is going to be 6.4. Did I make sense? With this knowledge, whatever the big number you have, you can easily divide by 5. Did I make sense? Like whatever the number I give you, like for example, let's take, I'm going to give you 18 divided by 5. What would be the answer? Try to make the denominator 10, so it will be easy for you to divide. So if you make the 5 to a 10, we have to multiply by 2. So the numerator also should be multiplied by 2, which is going to give you 36. So technically this becomes 36 divided by 10. So 36 divided by 10 is going to give you the answer as 3.6. Got it? So we don't have to use calculators, or we don't have to do this long division method also, like small kids. In 18, how many fives we have? We have 3. So 3 into 5, 15. We have a remainder 3. We have to put a decimal point. We have to take a 0 down. In 30, how many fives we have? We have 6. 6 into 5, 30. No remainder. So answer is going to be 3.6. Understood the point. Like understand the reasons behind everything, then you itself will figure out different strategies to work out. Any questions? That okay? Now, I mean, since I did this, I'll give you all another tip, okay? For multiplication. Now, can you tell me the answer? I mean, be honest, okay? You shouldn't use any calculators or no like long workings. Just tell me the answer for let's take 7 into 5. Within 2 seconds, you have to send me the answers.
35.
Very good. Okay. 7 into 5, 35. But if I ask you like 15 into 5. Okay, very good. 125. I'm sorry, 75. 15 into 5 is gonna be 75. 25 into 5 is gonna be 125. I'll ask another big one now, okay? Let's take 18 into 5. Okay. Now what if I ask you another one? Um, 27 into 5. Good job. Okay. Well done. So actually we have a strategy. I mean, depends on person to person, okay? When you have to multiply a number by 5, actually we can do a simple working for this. What actually you have to do is first multiply the number by 10, because multiplying a number by 10 is easy for you all, which is 70, and get the half of it. That's it. Because half of 10 is 5. So you can multiply by 10 and then you can get the half of it. So even if you have 15 into 5, first multiply the 15 by 10, which would give you 150, and get the half of 150, which is 75. Same thing, 18 into 5. First multiply 18 into 10, 180, half of 180, which is 90. You got it. So 27 into 5, you can multiply 27 by 10, which would give you 270, and get the half of it, which is going to give you 135. So now whatever the big number I give you, you will be able to get the answer if you multiply by 5. Is that point clear? Now what if I ask you 43 into 5?
215.
Well done. It's going to be 215, because 43 into 10 is going to give you 430, half of it. Half of 400 is going to be 200, half of 30 is going to be 15. So it's going to be 215. You got the point? All right, so let me ask you another question. What if I make it as 15? 43 into 15.
215.
43 into 15. Now it's going to be like this now. We need 43 into 10. Okay. We need 43 into 10. 43 into 10 is going to give us 430. We need 43 into 5 also. Okay. And then add them together. That's it. So 430 plus half of 430, which is 215. So it's going to give you 645. You got it. Well done. Yes. Good job. Most of the students, what they do, if I ask you 43 into 5, they'll be doing like this. Like small kids, 5 into 3, 15. 1 goes here, 5 into 4, 20, 21. 1 into 3, 3. 1 into 4, 4. Put a line and then 5, 4, 6. Like small kids. Understood? So these are some sort of strategies. Uh, can we use any multiple rather than 5 only? Exactly, you can. Now, what if I give you a complicated question? Like, let's take, if I give you something like this, 27 into 6. You guys know to find 27 into 5, right? 27 into 10, 270, half of it, 135. So 27 into 5 is going to give you 135. So we need 6 now. So which means we have to add another 27. Simply what you have to do, you have to add another 27 to 135. That's it. First add the 20 and add the 7. Did that make sense? So from the steps we know, we have to build up, we should know to build up different strategies for different questions. If it's like 27 into 7 means you need 2 more. Is that point clear? Now what if I give you like let's take 28 into 12. You can break the calculation, right? First you can do what? 28 into 10. Do mind calculations for this. We have 280. And then we need 2 more 28s, which would give us 56. So simply in the head itself, you can add 280 and 56. You got it? So at the beginning, when you guys are learning mental calculations, it will be a bit hard. It will be like confusing. But trust me, once you practice this a lot, by looking at the questions itself, you will be able to get the answers. I mean, automatically you will get some strategies, you will get some methods to solve. The reason behind learning mental calculation is because not to solve or not to get the answers for numbers, but to improve your thinking ability. So then only when you do a past paper question, and after that it's going to be like completely statements. You have to understand the question. You have to think of strategies. You have to think of methods. That will help you if you learn mental calculations because you are starting to use your brain, right? So it will be helpful. So trust me, learning again, I'm saying you're learning mental calculations, learning these different strategies is not to get the answer for these numerical questions, but to improve your thinking. Hope I made sense. All right. Okay, then we'll go to the next one, which is multiplication. We are done with multiplying whole numbers, multiplying a fraction by whole number. Now, the second thing that we have to discuss is multiplying a fraction by another fraction. Okay, now let's take 2 over 3 into 1 over 6. Tell me what would be the answer for this. Do you think here we have to make the denominators the same? Is it necessary? Actually, no. In addition and subtraction only, we have to make the denominators the same. When it comes to multiplication, we don't have to. The simple thing that you have to remember, the normal standard way is simply multiplying numerator by numerator, denominator by denominator. Okay, so 2 into 1, 2, 3 into 8, 3 into 6, 18. Now, since this is divisible, we have to simplify. 2 and 18 we can divide by 2. It's going to give us 1 over 9. This is the normal standard way. But here also we can do a small change. All right. Now, a very important thing, everyone, make sure to concentrate here. Very important. Very, very important. All right. Now, you guys know what is simplifying fractions, right? Can anyone tell me what is actually simplifying fractions? So here also we have done simplifying fractions. So what actually this simplifying fraction means? Okay, keeping the fraction in the simplest form or dividing the numerator and denominator both by the same number. Do you all agree with me? Simplifying fractions means, listen properly, dividing the numerator and denominator both by the same number. Here, that's what we have done here. We divided the numerator and denominator both by 2. All right, okay. Now we'll go back to the question again. Now, in this case, what is this 2? Is it numerator or denominator? 2 is going to be, just use N or D. No need to type it completely. N, D, that's it. Very good, numerator. What is the denominator we have for this 2? N is a numerator. What is the denominator we have for 2? No, my question is, what is the denominator we have for the 2? That is 3. All right. Now, my question for you is, for this 2, is 3 the only denominator we have? Is 3 the only denominator we have? Then who else? There we go. That is the main thing that you have to understand here. For this 2, 3 is not the only denominator we have. We can consider this 6 also as the 2's denominator. All right. The reason is because I told you in multiplying, we multiply the numerator by numerator, denominator by denominator. So 2 could be the numerator of 3 or 6 both. Is that clear? So when it comes to simplifying fraction, We are going to divide the numerator and denominator by the same number now. If you want to, you can simplify this 2 and this 6 as well, which comes under simplifying fractions. Are you all clear with that? So to make it even more like understandable, I'll give you all another example, okay? Let's take 4/10 into um let's take 2/6. Okay. So here the first numerator I have over here is 4. What is the denominator we have for this 4? There we go. Is 10 the only denominator we can consider for this 4? No, we can consider the 6 also as a denominator for 4. So if I want to, I can simplify this 4 and 6 in simplifying fractions by 2. So this would give me 2 and this would give me 3. Or I can simplify the 4 with 10 as well. So this would give me a 2 and this is going to give me a 5. Both are correct. Are you all clear with this? Okay. Now, what if I do a small change to the question? 4/10 plus 2/6. Now tell me, what is this for? N, very good, numerator. What is the denominator we have for this 4? Is it only 10? Exactly, it's going to be only 10, not 6. We can't consider 6 as a denominator for 4. A common misconception most of the students has. They'll be like, okay, we can simplify 4 and 6 now. Actually, no, you cannot. Because understand this properly, if you have addition and subtraction in between anything, these two people, what they do is they break the numbers into separate groups. So in a calculation, if you have addition in the middle or subtraction in the middle, they will be like, this is a different group, this is a different group. Like the operation you have in between, like boys and girls, something like that. If you, for example, in your school, um, so in this section, boys are going to be there. Let's say in this section, girls are going to be there. If the girls bring food, currently it's not happening, but yeah. So if the girls brought foods, you will be like, you will be sharing among you people, but not for the boys. So it's something like this. In between boys and girls, we have addition or subtraction, two different groups. But in between the girls, you have multiplication. In between the boys, you have multiplication. So it will be like one group, one whole group. Did I make sense? Okay. So here we have, in the first one, we have multiplication. No? So it's something like it's something like a one group actually. So you can consider 6 or 10 as a denominator for the 4. Are you all clear with this? Sure, everyone. So in this case, we can simplify this 2. So it's going to be 2, 3. Here it's going to be 1, 5. So final answer is going to be 2 into 1, 2, 5 into 3, 15. So here, in order to simplify, what we can do, I can cut this 4 by 10 only. Here it's going to be 2, here it's going to be 5. Here it's going to be 1, here it's going to be 3. Now if I have to add the two fractions, I have to make the denominators the same. So for 5 and 3, the common denominator we have is 15. So I have to multiply this by 3, this also by 3, this by 5, this also by 5. And that's how I have to solve. So it's going to be like 6 over 15 plus 5 over 15, which would end up as 11 over 15. All right, everyone, clear with this? Okay, now we'll come back to the practical question behind this multiplying fractions by fraction. In another 10 minutes, probably, yeah, Hakim. You're in a hurry to leave then. Anyways, so now let's check, is not Sabit, I'm sorry, Altaf, yeah? Is Altaf there in the meeting? Yeah, he's there. I will take the same two example, Altaf and Abdul Hakim, no? The other one? Yeah, let's take Hakim, okay? And Altaf. Now, Altaf has a pizza. Okay, so in his pizza, he's gonna have 6 pieces. And he's gonna give me 2 pieces now. Okay, this is Altaf's pizza, and these 2 portions are for me. He's gonna give this to me. Now, what is the remaining he has? Quickly tell me the answers. What is the remaining he has? Good job. It's gonna be, we can't give the answer as 4. If you say the answer 4, it would be incorrect because we have to give it as a fraction. It's gonna be 4 over 6. Now, what Altaf is gonna do is gonna give, listen to my statement properly. Altaf is gonna give half of the remaining to Hakim. Then for Hakim, how much Altaf is gonna give? He's gonna give half of the remaining he has. What is the remaining he has, Altaf? 4 over 6. Are you all clear with this point? So does this mean Hakim is actually getting half of the pizza? Is Hakim getting half of the pizza? No, there we go. Understood the point? Hakim is getting half of a remaining portion. This is what you have to understand. So when you have this kind of a question, like let's take, I'm gonna have 2 over 6. So no problem in this. I'm gonna get 2 over 6 from the total. All good. But when you're writing Hakim's portion, we can't say Hakim got half because Hakim is getting half of a remaining. In this case, what we have to do, of means multiplication. So we have to multiply half of 4 over 6. Since the denominator is 6, I'll keep the denominator as 6 as well here itself, okay? Without further simplifying. So I'm gonna cut this 2 and this 4. This is gonna give me 2. I'm not gonna simplify this 2 and 6 because I want the denominator to be 6. So 1 into 2, 2, 6. Simply 1/3. Yes, correct, Simra. Okay, actually, Hakim is also getting 2/3, not half. This is one of the main things you should know when it comes to fractions. Are you all clear with this? Everyone? Yeah, sure. I'll explain that with this question itself. Wait, let me share you the screen. I'll go to the past paper question we were discussing. Okay, everyone, concentrate now. If you do have any questions, any doubts, stop me there and ask me. Okay, we'll do this question from the beginning now. So A household water tank is completely filled with water. Okay, it's gonna completely fill with water. 1/10 of the water in the tank is used to water the garden. Okay, so let me use the red color. So for gardening, what is the fraction they have given for us? 1/10. So now tell me, Lamai, is this 1/10 from the total tank? Is it out of the total? Is it out of the whole? Actually, yes. From the total tank, only 1/10 have been used for the gardening, to water the garden. All right. And 1/4 is used for bathing. For bathing, they are using 1/4. Actually, this is also from the total tank because they have not said 1/4 of the remaining or 1/4 of the rest. Nothing is mentioned like that. So simply 1/4 is used for bathing in the sense from the total tank, they have used a quarter for bathing as well. Now, is that point clear? Now, actually, I cannot remember we did something called comparing fractions previously. So we have used the same strategy here also. Now, what they are saying is like for gardening, they have used 1/10. For bathing, they have used 1/4. It's a bit confusing for us to compare now. So in order to understand this in an easier way, we can make the denominators the same using equivalent fractions. For 10 and 4, the common denominator is going to be 20. So 1/10 would be the same as 2/20. 1/4 would be the same as 5/20. Are you all clear with this? So from the total tank, I'm gonna cut this into 20 pieces. Okay. So out of the 20, 2 pieces have been used for gardening. 5 pieces have been used for 1, 2, 3, 4, 5 have been used for bathing. Now tell me from this diagram, how much have been used in total for gardening and bathing? Come on. For gardening and bathing, how much they have used altogether? There we go. We got the same answer here also, na? You got the point, Lamai? So this is a practical way of understanding the fractions question. So we have done so far from the basics we have done, right? So that is the same answer we will be getting over here also. So to find the total of gardening and bathing, we have to add 1/10 plus 1/4, which is going to give us 7/20. Now tell me, in the tank, what is the remaining we have? What is the remaining fraction we have? What is the remainder, the balance we have in the tank? Understood? Okay, now we'll go to the second question. The second question says, of the remaining water in the tank, 4/13 is used to wash clothes. Is that point clear? Now, from the remaining, okay, to wash clothes, for the clothings, they have used 4/13. Is this 4/13 from the total? No, this 4/13 is from the remaining. So 4/13 of the remaining. What is the remaining we have? Remaining we have is 13/20. Are you clear with this? So information they have given is what? 4/13 is to wash the clothes. But this 4 over 13 is not from the total. The 4 over 13 is from the remaining. If we have to find the fraction for clothing out of the total, we have to multiply these two fractions. So what I'm going to do is I'm going to multiply 4 over 13. Okay, how is the remaining came? Good job. Good question there. So how the remaining came was for washing clothes, not washing clothes. What's the first one? Gardening. For gardening and bathing, the total we got was 7 over 20. Do you agree with that? The first question's answer. For gardening and bathing, the total we got was 7 over 20. It's something like out of 20 pieces, 7 pieces have been used for these two. Then out of the out of the 20, what is the remaining part we have? So how many remaining pieces we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's something like from 20 chocolates, you have given 7 to your brother. So what is the remaining you have there? 13. Is that clear now? Himasha? Okay, great. All right. So now they are saying 4 over 13 is used from the remaining. So what we have to do is 4 over 13 should be multiplied by the remaining, which is 13 over 20. Now, can you tell me how to simplify this? I can simplify 13 and 13, right? Because we have multiplication in the middle. Now, a small tip. Actually, you can simplify 4 and 20 as well, but don't do that. Write the fraction as 4 over 20 and then write the simplest form, 1 over 5. The reason why I'm asking you to keep it as 4 over 20 is because for the first two, the denominators we have are 20. So it will be easy for us to compare. If you write it as 1 over 5, again you will have to convert the denominator 5 to 20. It will be like 2 or 3 things to do again and again. So better write this 4 over 20 and then write it as 1 over 5. All right, clear now? So now tell me from the total how much they have used for washing clothes. For the washing clothes, they have used 4 over 20 or 1 over 5. So we'll put that 4 pieces for that also. 1, 2, 3, 4. Now tell me, what is the total amount they have used altogether? For gardening, 2 over 20. For bathing, 5 over 20. For washing clothes, 4 over 20. Altogether, they have used how many? Quickly, quickly. There we go. If 11 over 20 has been used altogether, what would be the remainder? There we go. That's the next question you have. Find what fraction of the tank remains filled now. That's it. Which is 9 over 20. See, from the basics, we have answered 3 questions. Only one more to go. Understood the importance of learning the basics to learn O-level parts. Are you all clear with this? Yeah? Okay. Anyways, I think I have taken 2 extra minutes. By the way, we'll complete the rest. Okay. So Lamai, actually, I have shared the well, let me open and show it to y'all. Okay, so I have already shared you all the PDF. Okay, it's there in the website. I think everyone knows how to access the website. Yeah. So let me show it to y'all. So this is the document I have shared y'all. So in this we have 2016 to 2024 past paper, O-level paper. All right. So make sure to try out everything. Okay. So probably in the next class, I'll discuss all these questions. All right, so make sure to download the document. It's free. You all can download it and then work it out. We'll discuss these questions in the next class. All right, so next week also it's going to be the same time, 5 to 8. All right, so by the way, before ending the sessions, do you have any questions or any doubts? How to download? Well, let me show it to you all. So if you go to the Google and search this EduZone link, okay? So you just have to log in as a student. Let me show you. So you will be able to see my class poster there. Okay, so click login to Wave and then go to register. You have to give a phone number or email or anything and just a password. All right, and then go to register. You will be able to log into the what do you call the classroom. And how to get the recording for this session? I'll be uploading the recording for the same slot. So if you log into that, you will be able to get the recordings also. By tomorrow, you will be able to get the recordings. All right.